Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 8. The single plate clutch transmits the torque C from the input shaft on the left to the output shaft on the right. Compression springs between the clutch housing and the pressure plate provided the necessary pressure on the friction surface. The splines prevent the clutch plate from rotating relative to the output shaft. If R inner is 4 inches and R outer is 9 inches, determine the total force that must be applied to the pressure plate by the springs if the clutch is to transmit a torque C 56 pound-foot when it is new. So here is the figure. Then this is the couple, mu sub s 1.6. This is the contact surface. RO is R sub 2, 9 inches. RI is R sub 1, 4 inches. And the formula for moment or couple is 2/3 mu sub s P times the quantity R2 cube minus R1 cube over quantity R2 square minus R1 square, where R2 is also R outer 9 inches and R sub 1 is 4 inches, R inner. And let's express the couple into pound inch by multiplying this by 12. So formula first, then substitute. So 56 times 12 equals 2/3 of 1.6 times P, quantity 9 cube minus 4 cube over 9 square minus 4 square. So solving for P, which is the only unknown, P is equal to 61.58 pounds. Level 9. The disc clutch is used in standard transmissions of automobiles. If force springs are used to force the two plates A and B together, determine the force in each spring required to transmit a moment of 600 pound-foot across the plates. The coefficient of static friction between A and B is mu sub s 0.3. So for the solution, again, the moment is equal to 2/3 mu sub s P times the quantity R2 cube minus R1 cube all over quantity R2 square minus R1 square, where R sub 2 is the outer radius, in this case 5 inches, and R sub 1 is the inner radius of the shaft, of the hollow shaft, hollow disc, which is 2 inches. Then P is, since there are 4 springs and we are required to compute the force in each spring, and we just substitute P equals 4 times Fs. So substituting with M converted to pound inch by multiplying this by 12 inches per foot. So 600 times 12 equals 2/3 mu sub s 0.3 times 4 times force in each spring quantity 5 cube minus 2 cube all over 5 square minus 2 square. So it's the F of spring that is unknown here, the only unknown. So using your calculator, F sub s is equal to 1615 pounds. Level 10, the double pulley shown is attached to a 10 mm radius shaft that fits loosely in a fixed bearing. Knowing that the coefficient of static friction between the shaft and the poorly lubricated bearing is 0.4, determine part A approximately and B accurately the magnitude of the force P required to start raising the load. So here is the given figure. So for the solution, since the requirement is to solve for P approximately in part A, then accurately in part B, required magnitude of the force P required to start raising the load. So it means that the moment should be, the effect of this P here would be to rotate this double pulley in clockwise direction, so therefore R should be just to the right of the center of the axle, which is here. And the formula in computing for the moment is reaction times radius of the shaft, which is 10 mm or 0.01 meter, times, if it is approximately, times mu sub k, or mu sub s in this case, because it's just a problem on, or motion is impending upward for the 20 kilogram load. So moment equals reaction times radius of the shaft, axle, this one, then shaft, then mu sub s, where R is summation forces y, P plus 20 times 9.81, and the moment is, the moment due to P should be greater than that of the 20 times 9.81 Newton tension here. So it is P, moment is P times 0.045 meter, then minus 20 times 9.81 times 0.09 meter. So that's the moment, P times 0.045 minus 20 times 9.81 times 0.09. Simplifying, moment equals 0.045B minus 17.658. Then for this reaction, summation forces y, R is equal to P plus 20 times 9.81. Simplifying, R is P plus 196.2. Substitute into this equation formula here, and moment is equal to this in Newton meter. Then R is P plus 196.2 newtons. So the radius of the shaft should be in meter also 0.01, then mu sub s 0.4. So moment 0.045B minus 17.658 equals quantity P plus 196.2 times 0.01 times 0.4. So simplifying, 0.041P equals 17.658 plus 0.7848. Then we can now solve for P. P is equal to 449.8 newtons approximately. For the accurate calculations, we replace mu sub s by sine of P sub s. So moment equals R reaction times radius of shaft sine of P sub s, where P sub s is inverse tangent of 0.4, or tangent of P sub s equals 0.4. So P sub s is equal to inverse tangent of 0.4, so 21.801 degrees. Then substitute into the formula here. Moment 0.045B minus 17.658 equals quantity P plus 196.2 times 0.01 sine of 21.801 degrees. Simplifying, 0.041286P equals 17.658 plus 0.72866. Finally, P is equal to 445.3 newtons, and that's the value of P when we use the accurate formula.